Hello, welcome back. This is Sam. In the previous video, we looked at this screen and we stopped here. And we say that we are going to input our problems now. I mean, this our problem is going to be input. And we said we want to change red to yellow. And remember, this input, we split them to many functions and we wrote them to about 5 functions. And we are going to input it into the system so that this system, the processor now processes it according to the logic that we are programming our function in order to produce the output B. But we have done our function recursively. Then I said, I'm going to tell you what recursive is all about. Recursion is one of the algorithm implementation techniques. I can best describe it mathematically. Look at it in terms of uh, in terms of a set of rules or a definition or some kind of procedure that you apply it repeatedly, to produce the successive result. The result could be like each time when you apply that function, you use the same function to apply on this on the next on use the result from the previous application in the new function and then apply again and use the previous result in the new function and apply again until when you get the answer. So the first step is called the base step, the base step. And that base step is just the beginning. It's like to verify the problem, to verify that there exists some solution at the step one. And that is why I wrote here, in the first part of our algorithm, we have the function that define what red is. So we have to define what red is and what yellow is. But because when you know yellow, red, how can you define that in terms of technology? So we have decided to come up with some code like 123 is the code for red, and then 789 is the code for yellow. You see, now we're doing what is called encoding, data encoding. So that if we want this yellow, because the light was really red, so that if you want to turn the light from red to yellow, this code here must change to that code in order to produce yellow light. And that is the idea, and that's how we break this thing down. So now the first step of the recursion or recursive step is called the base step, the base case, is to define what yellow is and what red is. And we have defined it. Remember, this is just our conventional way of defining. It's not the actual code for this color, but I just choose any number to say, okay, this 123 means red and 789 means yellow. It's just the encoding system that I have taken randomly from my mind to work with. Okay, so now we have defined our rate, the input and the output. So this is our input now. Is the problem. The problem is we have red and we want to change it. So our target is to use recursive. I've talked about recursive. So the best case, when you use the best case, is like we are not going to get any major to do any major repetition. So when we do that, we will just get immediately we get B equal to B. But recursively, we are now going to apply that result on this function over and over again until when we get there. But that is just what will happen. But it's not going to be here, but I'm assuming we are using recursive method. So another function, remember this thing is now happening inside our system. After inputting, we are now reading the function. We want to link the mismatch. So we are linking red and we are linking the codes of red to the code of yellow, such that when we give that one to the input system, now the input system will take our function. Remember all the 5 functions we have written here. And the first bit of it is to define, the first step was to define the color. That's why it's here. This is the recursive step. I mean, the best case has been done already. We define the color, and now we are trying to link. That is now the recursive stage. So we are linking the code for for red to yellow, so that we can be able to transform this link, this 1, 2, 3 must be transformed to 7, 8, 9 in order for us to get the what? The yellow. Because everything must be yellow in order for us to get yellow. Like here you can see everything is red and there everything is yellow. So we don't want to mix. So the link mismatch is this one. So we want to work on this. This is the problem we want to solve, you know. Now when we input this in the system, when this has been inputted into the system, the processor, now this function here, the input system, will take it and change it into the binary code, because now the thing has been now compiled. We are running the program now, so it will change to the binary code. You see the code, so the entire program now has been embedded here to the byte code, not binary. And then from here it will change to binary. So it is this version now, which is a platform independent version of Java, if you like, because like when you package it into the jar file, you can now go and install it in any computer and run it with any operating system, because now from here all the codes will be converted to bits so that the processor can start doing its work. So I'm going to do this bit by bit so that you understand. I'm not going to finish this video on the processor. We are going to do the processor next. But what I would like you to take home is that we have now sent the the algorithm now has been sent to the system. That is why the input unit is now doing its work. It has received our algorithm, and now it is doing the translation to change our algorithm from the source code into the bytecode, which is platform independent because it contains the Java virtual machine. And the Java virtual machine is an interpreter which will change this one now to the machine code. And the machine code is the binary representation of bits, an hexadecimal, hexadecimal and binary instruction. They are all going to be changed into 10100010. Everything will be in ones in order for the processor to start processing according to how we have programmed using those functions. So those functions now have to operate here in order to generate the output. And that's what you're going to see next in the next video. So thank you for viewing. I hope you are enjoying this.